This is Chapter 2, Section 8. We're going to be graphing inequalities and absolute value equations. So it's something kind of familiar, but we're going to be kind of detailed with it. Let's start with example 1. We're going to graph what we call compound inequalities. That means we have two different inequalities. We're either going to put the word or between them, which then makes them a disjunction, or in later problems put the word and between them, which makes them a conjunction. Let's start by solving these individually. If you were solving 6y less than negative 24, you would divide both sides by 6 and get y less than negative 4. Solving this one individually, you would subtract 5 or get y greater than or equal to negative 2. Graphing these, which is part of the instructions or directions, require us to graph the part that's less than negative 4 with an open circle and the part that's greater than or equal to negative 2 with a closed circle. So we make our graph go this way. Let's talk about a couple of things that happens over here. You'll see that they've written the answer, the solution, in set builder notation. They've also written the answer in interval notation. This tells you that our set of numbers goes from negative infinity to negative 4, or, that's what that little u means, negative 2 to infinity. You'll notice the bracket here tells us that the negative 2 is the only value of the 4 that's included. The rest of these three are parentheses, which means they are not included. Okay, let's solve a compound inequality that's a conjunction with an and between it. Having the word and tells you that you're going to get a number set that is not going to have a hole in it or an or here. To solve the left side, think, how do you get rid of 1/2? You're going to multiply both sides by 2. You're going to get c greater than or equal to negative 4. To solve this side, we're going to subtract 1, giving 0 over here, and then we're going to divide by c. Divide by 2, gives us c less than 0. On the left side, we multiplied by 2, got c greater than negative 4. On the right side, we subtract 1 to get 0, then divide by 2, still getting 0. Taking this and graphing it, we start at negative 4 and make our arrow go to the right. So we color in our circle because of the greater than or equal to sign. Coloring it in, starting our arrow to the right. You have to stop this solution though, because you also have to satisfy this part, which says that it also has to be less than 0. So we graph the part between negative 4 and 0. Notice that this doesn't have an equal to, so our circle is open. The interval notation should be pretty easy for you to do now. We go from negative 4 to 0. Negative 4 is included, so remember we use a bracket. 0 is not, so we use a parenthesis. Okay, example 3 starts the absolute value solution. We're going to solve an absolute value problem by remembering that we could have a negative 10 for our answer or a positive 10 inside of here. So we need to write out two solutions. We drop the absolute value line and we write negative 3 plus x equals positive 10. And we make another solution on this side, which is negative 3 plus k equals negative 10. Solving this part and this part is a simple algebra problem, so we're going to go through it kind of quickly. We get k equals 13 or k equals negative 7. So think about this for a minute. Either 13 or negative 7 can be plugged into this equation, taking the absolute value of it and still getting positive 10. You can also think of this as the distance between k and negative 3 is positive 10. Another problem that looks a lot like this one has the absolute value of x over 4. Minus 6 equals negative 2. I cannot say this word enough, but you need to isolate, isolate, isolate. When I say that, I'm talking about the absolute value because before you apply this step, you have to get this by itself. How do you get this by itself? You're going to add 6 to both sides. Adding 6 to both sides gives us x over 4, all inside the absolute value, equals 4. Now that we have it isolated, all by itself, we can follow this step up here. We're going to set x over 4 equals to positive 4, or x over 4 equals negative 4. Again, remember you drop the absolute value in this step. You keep it in this step, but you drop it in this step. Solving this for x, we need to get rid of the dividing by 4. The opposite of dividing is multiplying. So we get x equals 16. Solving this side for x, we're going to multiply both sides by 4 and get x equals negative 16. Either of these numbers, when plugged into this absolute value, subtracting 6 will give us negative 2. Okay, this next problem is another inequality where the absolute value is already isolated, but this time it also has an inequality, so it's not an equal to anymore. What happens when you have this type of problem is you copy the absolute value part, you copy the greater than or equal to, and you copy the 10. When you go to the right side, however, you make another solution where you copy the absolute value part, but you change two things. See if you can notice what the two things are that change. You should notice that the 10 became negative and the greater than or equal to was flipped. So when you have an absolute value and an inequality, you write the first one as is, you write the second one flipping and making this a negative. Solving this one, using our Algebra 1 skills, we're going to subtract 2 from both sides, giving us negative 4q is greater than or equal to 8. This one we're going to subtract 2 from both sides, giving us negative 4q less than or equal to negative 12. You'll notice that we're going to divide by a negative, which means both of these signs are going to flip. We're going to get q less than or equal to negative 2, or q greater than or equal to 3. Graphing this on a number line, we have the solution less than 2, the arrow goes this way, less than negative 2, and we have a solution this way, greater than or equal to 3. We can write it out in interval notation the same way we did the beginning of this section. We can also now plug in some test values. You could plug in any number in this range. They're part of your solution, so they should work. I tried negative 3. When I plugged it in, I got 14, which is clearly greater than or equal to 10. A value in this part shouldn't work. I plugged in 0. 0 was plugged in. 2 is not greater than or equal to 10, so it didn't work. And I plugged in a value in this range, 4, positive 4, and I got negative 14. Absolute value, which becomes 14, is greater than or equal to 10. The last one is we're going to take this absolute value. We notice the inequality, but before we do anything, we got to get rid of this guy. So we're going to add 3 to both sides. We're going to get 0.5r greater than or equal to 0. In other words, we've isolated the absolute value. Setting this equal to the positive version and flipping, there is no negative version of 0. We're going to divide both sides by 0.5. We're going to get r greater than or equal to 0 or r less than or equal to 0. When you graph this one on a number line, it starts here and goes this way. When you graph this one on a number line, it starts here and goes this way. Because 0 is included, the answer is the entire number line, which is all real numbers. Usually we indicate it with the capital R. Okay, example 4 is in the other video, so make sure you watch the other video also.